Hello, Chemistry 10HH students. This is Mrs. Altman. We are on video number 17, Atoms, Molecules, and Ions, Part 4. Here are our objectives for today's video. Pause here. We're going to now start switching our focus from elements to compounds, and specifically how we name compounds. Before we're able to name compounds, we're going to need to differentiate between things that are ionically and covalently bonded, because they're going to have different naming conventions. So when we have covalent bonding, which you'll typically see between two or more nonmetals, then you'll have the sharing of electrons to form some sort of bond. And then we'll have ionic bonding, which is going to typically occur between a metal and a nonmetal, where one atom completely donates electrons to the other, so they're not shared. Technically speaking, ionic bonding is not bonding. I define bonding as constructive overlap of atomic orbitals. All that means is that the orbitals overlap and then they actually add together. But if we have donation from one atom to the other, then you cannot have overlap. So ionic bonding is technically not bonding, but there's a historical reason why we still call it that. Pause here. All right, so before we get into actually writing formulas for the compounds, we just need to do a little refresher. We're going to do simple formulas. So if I don't say full atomic symbols, that means that you don't need to do those. So just remember your common charges. So that's what we did last video. You should be at the point before we have any sort of testing where you could just know the charges. Maybe you'll want to put them on your periodic table, but it shouldn't be something that you have to take a lot of time to think about. Some of you might prefer to do -2 instead of 2-. That's completely fine. That's just a personal preference that I do 2-. So just know your common charges are going to be super, super important at this chapter. Pause here. So we're going to have 3 types and then acids. So the first is our type 1 binary compounds. So this will, a compound is binary if you don't already know it, if it consists of 2 types of ions or 2 types of atoms. Everything we're going to be looking at this chapter is binary. So a type 1 compound will contain a cation from groups 1, 2, or 3, and an anion. So essentially not a transition metal. So a metal and a nonmetal, the metal is not a transition metal. First, we name the cation first. So an example of this is sodium chloride. So it's just sodium for the first word. And then the second element is named second, which is going to be the anion. And then the anion is, you change its suffix to IDE. So originally it had, let's say, sodium chlorine, and it becomes sodium chloride. Pause here. So the subscripts actually don't affect it for our type 1s. So we have sodium sulfide, potassium chloride, calcium fluoride, and aluminum oxide. Pause here. So now with our type 2 binary compounds, it gets to be a little bit more complicated. So we have a transition metal and some kind of anion. The cation we need to name using Roman numerals. The reason why is that a lot of the elements that are in the transition metals can actually have more than one charge. So we need to say what that charge is. So for Fe2+, it's iron 2. If it were 3+, it'd be iron 3. Has to be in Roman numerals. You're not going to see anything higher than, the absolute limit would be 10, but I can't think of a time I've ever assigned anything that was higher than 6. And then just as before, the anion is named by changing the suffix to IDE. Pause here. Okay, I'm going to show you a sort of trick that a lot of students like to use. You might not need it. You might just get to the point where you can do these in your head, but I'm going to show you at least once. So what I do, if there's no number listed by the metal, I just put a 1 there, and then I'm just going to put in X, and then I go to my periodic table. I find chlorine's common charge, and it's -1, and then 1 times X plus 3 times -1 is equal to 0. I solve, I get here that X is equal to 3. So then when I write this out, it becomes iron 3 chloride. I'll quickly do the others. So I've got HGO. I've got one Hg with a charge of X. I've got one oxygen with a charge of 2 minus. 1x plus 1 times -2 is equal to 0. X is equal to +2. It's always going to be positive charge. You're never going to get a negative. So this becomes mercury 2 oxide. And you're not going to have to write it out like that every time. I certainly don't, but it's just a trick that makes it a little bit easier for students. And then this last one I'm going to do in my head because I can see I've got 2 phosphoruses, each with a charge of -3, so a total charge of -6. Therefore, I must have a +6, so my charge of copper will be +2. All right, pause here. So I'll show you 2 of them on the whiteboard, and then you'll probably get to the point where you can do these in your head if you can't already. So I list my elements. So I've got Na and I've got N. The charge of Na is +1. The charge of nitride is -3. So what I do is I just take that 1, I put it down here, and this N3 and bring it down here. This just ensures that I've got equal numbers of positive and negative charge. So I've got Na3N for my first one. For the second one, I've got iron, and then it says in parentheses 3+. So they put that up there. Chloride, chlorine's common charge is -1. Crisscross applesauce. So FeCl3. And then I'll do the other ones not written out. You're not going to always have to write them out, but that trick is just help students at first. And then this one, you end up first with Mg2O2, but you have to simplify. So we just get MgO. And then for your next one, you get Mn2O4, but you have to simplify that to MnO2. Great. That is all for today's video. Thank you so much for watching and have a great night.